Well, the answer seems to be that there's 5 billion bits. 5 billion bits of information in our encyclopedia of life, in the nucleus of every one of our cells. So if written out in, say, ordinary English, those instructions, that information, would fill 1,000 volumes. Think of it. In every one of the 100 trillion cells in your body, there's the contents of a complete library of instructions on how to make every part of you. Those cells are smart. If what we had to do was so complicated that even several billion bits of information wasn't enough, what if, for example, the environment were changing so fast that the pre-coded genetic encyclopedia, which may have served us perfectly well in the past, is now not perfectly adequate? Why, then, even a gene library of 1,000 volumes wouldn't be enough. That's why we have brains.
A clip there of an old TV show, Carl Sagan. He had a TV show called Cosmos, and that's an episode entitled Persistence of Memory. When I was a kid, I used to love watching that show, and I still think it stands up pretty well today. I was just recently rewatching that episode, and he talks in depth about the brain. I think you'll probably be able to find that episode somewhere on YouTube if you look around, and it's well worth it because Carl Sagan knew how to make episodes of television that were very educational, to say the least. But I just wanted to briefly look at a couple of points. He basically talks about data and how everything is memory, and that we have so much data in our DNA and then so much data in our brains. And that's why we need brains, because we need to extend that data. So you might have a dog, for example, have certain data for dog activities, but to have higher activities beyond instinct, you need a brain because we have thought. And then he'll talk about the different structures of the brain, and later in the episode he'll talk also about we have to also have storage beyond the brain to form a library. So you have the DNA, the brain, and libraries, and every one of them in one way or another is a storage device of memories, and the persistence of memories and bits of information. It's quite a fascinating idea, and ties up well as well with a lot of the ideas of physics, which is based on everything. Every piece of matter is basically a piece of information. It's an interesting concept. What I want to touch upon here today is the idea of brain structure. And we're just going to have a quick look at the structures of the brain as described by Carl Sagan. I still think they stand up pretty well. Let's take a quick look.
Like our other organs, the brain has evolved, increasing over millions of years in complexity and information content. Its structure reflects all the stages through which it has passed. The brain has evolved from the inside out. Deep inside is the oldest part, the so-called brain stem. It conducts many of the basic biological functions, including the rhythms of life, like heartbeat and respiration. The higher functions of the brain have evolved in 3 successive stages, according to a provocative insight by the American biologist Paul MacLean. You see, capping the brain stem is the so-called R complex, R for reptile. It's the seat of aggression, ritual, territoriality, and social hierarchies. It evolved some hundreds of millions of years ago in our reptilian ancestors. So deep inside our brain is something rather like the brain of a crocodile. Surrounding the R complex is the limbic system, or mammal brain. It evolved some tens of millions of years ago in ancestors who were mammals, all right, but not yet primates like monkeys or apes. It's a major source of our moods and emotions, our concern and care for the young. And then finally, on the outside of the brain, living in a kind of uneasy truce with the more primitive brains beneath, is the cerebral cortex, evolved millions of years ago in ancestors who were primates.
So, what Carl Sagan is basically saying here is that we have three structures of the brain. Okay. And this tree structure idea is that we have the brainstem, which goes back hundreds of millions of years. And the brainstem is basically the instinctual brain, the reptilian brain, or complex as he calls it. And basically it's about survival. Its brainstem is right back here. It's the brainstem. Many snipers in the army will attempt to shoot somebody in the base of the brain because it results in instant death and also zero suffering apparently. So the brainstem is things like you come home from work or home from school, you don't remember how you got there, that's coming from the brainstem. You know, if you look at a lizard, you got a lizard in your house around the wall, and you sit there quietly and you just look this way, and then next thing they see something and they either move or their tongue pops up, grabs it. That's reptilian thinking. So peripheral vision, how to drive home, how to walk home, how to brush your teeth in the morning. This is all coming from the brainstem. It's about survival, it's about fight and flight, it's about instinct, it's about hierarchy and dominance. It's humans at their lowest, and we see a lot of people with reptilian type instincts and activities, which are about dominance and hierarchy and kicking the other guy, and survival. And that's the most basic level of the brain. The next level that we have up upon that is basically the limbic system, and the limbic system is an area of the brain which is dealing with the emotional side of life, when we have fond memories of people, and we have soft feelings and emotionality. That's the limbic system, and that developed over tens of millions of years. And then on top of that, we have the cerebrum. So the system is very cerebral, the top part of your head or your brain, and that's where we do cognitive thinking. So what I think is very interesting, and it's demonstrated nicely in this TV show, is that they developed over time. So a bit like if you look at computers, I'm not sure if it's working this way, but traditionally how the PC developed, you had a thing called MS-DOS, which is basically a very basic kind of operating system. And then on top of that, you built different layers of operating systems and so on. And basically, if you look at your computer has the machine, and then it has a machine language. And the machine language, so if I type on my computer, there's a thing ASCII, ASCII, I think it is, which converts my G or my H or my W or whatever, it converts it into a binary number, okay? And then the computer understands zeros and ones. That's how they work. They can't understand fractions. So we also have the screen. So we're now looking at screen on your device. You're looking at me here. And this is the GUI, the graphic user interface. Graphic user interface connects into the hard drive and the processor. Processor processes the information. Hard drive stores the information, as does RAM, rapid access memory. And you also have then an operating system which tells the computer what to do. And of course the hard drive is whizzing back and forth information. And then you have a conversion to machine language, which is pure binary. And then you actually have the machine. And at a very basic level, this is what people don't realize. You think of software and hardware. But actually, again, watch this video and he'll touch on this point. There's a convergence between software and hardware. Because I might say, well, I type a bit of software and I create a little program. The program says, as soon as this gets up to 100, okay, it will decrement, it will go down by 5 or something like that. So I can have that for, basic calculations, creating an online calculator or whatever it is. I'll use increment and decrement and a thing called modulus. These are basic little mathematical functions. But that's on the software. But on the hardware, it does actually affect the hardware. So you have this converts into zeros and ones, and then it actually goes down to actual electricity moving along the channels of the circuit board on the computer, which is creating activity on the computer, which if it ties to a machine could be creating activity in the machine. The same thing with your thought. Your thought is an ideation, but that's the software. And then the operating system is how your brain is wired, how you program, and that you can reprogram your brain. You're programmed to some degree by genetics, you're programmed to some degree by environment, you're programmed to some degree by the choices you make and how you reprogram. And also then, on a physical level, we have neurons firing, and neurons are basically a mixture of electrochemical, the electric charge, and then they release the chemical, and that chemical goes from one neuron to another and creates a chain reaction. And there's a lot of connections all over the brain. billions of neurons as far as I'm aware, and many, many connections. And that's the physical side of our thought. So our thought, on one level, is pure ideation. On another level, our thought is an actual activity in the brain. And that can, of course, result in a physical activity, like you might reach out and grab something and like drink my cup of coffee or whatever, okay? So it's very similar kind of analogies. Let's take a look at another little clip in here where he talks about how we might be able to go beyond instinct, because the challenge we had at the previous thing which is there, which is basically that we've got an instinctual side, we've got an emotional side, we've got this cerebrum, and how do we balance them? And let's just take a quick look here.
This is the point of embarkation for all our cosmic journeys, the cerebral cortex, where matter is transformed into consciousness. Here, comprising more than 2/3 of the brain mass, is the realm both of intuition and of critical analysis. It's here that we have ideas and inspirations, here that we read and write, here that we do mathematics and music. The cortex regulates our conscious lives. It is the distinction of our species, the seat of our humanity. Art and science live here. Civilization is a product of the cerebral cortex. Behind the forehead are the frontal lobes of the cerebral cortex. They may be the places where we anticipate events, where we figure out the future. But if we can foresee an unpleasant future, we can take steps to avoid it. Down here in the frontal lobes may be the means of ensuring human survival if we have the wisdom to pay attention. Inside the cerebral cortex is the microscopic structure of thought. The language of the brain is not the DNA language of the genes. What we know is encoded in cells called neurons, tiny switching elements, every connection representing one bit of information. How many neurons do each of us have? Maybe 100 billion, comparable to the number of stars in the Milky Way galaxy. And there are something like 100 trillion neural connections. This intricate and marvelous network of neurons has been called an enchanted loom, where millions of flashing shuttles weave a dissolving pattern. Even in sleep, the brain is pulsing and throbbing and flashing with the complex business of human life, dreaming, remembering, figuring things out. Our thoughts, our visions, our fantasies have a tangible, physical reality.
So, he's talking about the frontal lobes. And what's interesting with the frontal lobes he's talking about is basically how you make decisions. And when a person's lobotomized, they actually put a little thing in here, or they can go through the nose to get the same thing. And there was a trend in the early 20th century, they're lobotomizing people left, right, and center for all sorts of things. But traditionally it was to, pacify somebody who was insane. And basically takes away free will. And the way it kind of works is that at the age of 25, the frontal lobes are fully developed. So before 25 years of age, we're not fully mature. The brain is not fully mature. And of course, you could say, well, is the brain ever mature? We have to keep maturing. But the interesting thing with the frontal brains is around the age of 25, you can fairly well take a mature decision. Before that, there's a lot of jumping around and being instinctive and so on. And what he's emphasizing here is that the moderating thing, okay, you've got this reptilian brain which wants to either run away or beat people up. You got this limbic brain who wants to be emotional. You got this referee type cerebrum that's trying to work out the best way forward. And this part here, the frontal lobe, frontal cortex, is basically where we make decisions. And if we can learn to make wiser decisions and better decisions, we can choose when and where to do something or not do something, to engage the brain or not to engage the brain, to engage in maybe running away, to engage in maybe being fighting somebody, to engage in being maybe more emotional or less emotional, and that really there's an element of choice. So I just thought it was very interesting about this episode. It's a great show if you can find it. I think there's a lot of episodes still there on YouTube for free if you look around. Well worth seeing it. They did remake the show recently, but it's garbage compared to the original. So yeah, you have different layers of your brain, and this is going to affect you because you'll have an instinctive side, which is into fight or flight. You'll have an emotional side, and you have a thinking side, a cognitive side. But we also have a decision side, which is the frontal cortex. And what I think is very interesting is that if we really want to have power over our lives or control over our lives, we have to realize that we have many challenges, because we are like an intelligent primate. I don't see that in a derogative way. I'm just saying that there's many similarities. Even if you look at societal structure, very similar to ape structure, and that's not criticism of apes or humans, but I'm just saying that there's many similarities. And I'm not saying that we descended from an ape, but certainly we are in some ways related to apes. Evolutionary, there's some connection there, and that there's an aspect of us that's like that. So we can think in terms of higher or lower, or that there's a humane side and potentially a divine side, but there's also an animal side as well, and that the animal side will be driven by fear, it will be driven by aggression, it will be driven by all the usually lower sides and instincts, and there's a higher intellectual side. And then how do you find a way forward? And so these are challenges that every human being has to face, the lower and the higher aspects, because you have in one way you could say we're an intelligent monkey. There is, Homo sapiens sapiens is the official title, which actually means great white ape. Created by the old Europeans, or probably Britishers maybe. The idea of the great white ape, they used terms like that back those days. But the point is, Homo sapiens sapiens, we are related to the ape family, and we act like apes. And apes are big into societal structures, and they're into things like dominance hierarchies, and all this stuff, which you see a lot on my channel, all that sort of stuff. So what are you going to do about it? And this is, if we don't have an awareness of the brain, and don't have an awareness of evolution, where we came from or how we're wired, it's difficult, and you might suffer and think, why is the world the way it is, and why are people the way they are? Well, this is why, because we came from a certain background. But as Carl Sagan says in this Persistence of Memory episode in Cosmos, this TV show from around 1980 or so, is that we can develop our decision-making skills, and this is one way forward. So just thought I'd share that with you today. Persistence of Memory is the episode. Cosmos is the TV serial, well worth looking at it. And if you want to feel happier about life, I would strongly recommend learning a bit about the brain, how it works, and it will make you feel a bit more philosophical about why people do the things they do, and also show you a way forward and how that we can maybe improve our decision making and try to mediate better this eternal conflict as human beings between the animal side and the more higher level aspirational side. Hope you liked the video. If you do, please like and subscribe, and I'll talk to you next time.